Okay, so I want to give you guys one more example of these problems involving Hess's law. And I'm looking at the second problem on page 136. For this one, I'm going to go through my strategy and tell you how I'm going to come up with my strategy. And then I'm going to ask you guys to finish the problem for me. I want you to prove to yourself how do you add the equations together and get your value for delta H of reaction, and you can check it with my answers on Blackboard. Okay, so remember the equation up top, the one in bold, is my target equation. The first thing that I'm going to do is I'm going to identify my reactants and my products in the target equation. So I'm going to start by circling my reactants. So I got nitrogen dioxide reacting with hydrogen gas, and my products in my target equation is nitrogen gas, this half mole, and also these 2 moles of water. I'm going to figure out, my strategy here is how do I modify equations 1 and 2 so that I can match that target equation up top. Just like before, I'm going to number my working equations. So I'm going to call this equation 1, and I'm going to call this equation 2. And I want to come up with a strategy of what am I going to do to equation 1 and what am I going to do to equation 2 so that when I add them together, I get the target equation up top. Okay, so what I'm going to do is I'm going to look for my reactants, the ones that I circled in red, in both equations 1 and 2. I want to figure out where are they. So if I start with the nitrogen dioxide, what I notice is that it only appears in one spot. The only place it is right here in equation 2 on the right-hand side. Now if I look for my hydrogen gas, my other reactant, it appears in 2 spots. I have it up above here in equation 1, and I've also got it down below here in equation 2. Now I want to locate my products. Where do the products show up in my equations? So if I start first with the nitrogen, nitrogen only shows up in one spot. It's in equation 1 and it's right here on the product side. There's my nitrogen gas. The water that I have up top, my other product, the water is in equation 2 and it's also only in one spot. It's over here on the left-hand side. Okay, now based on finding my products and my reactants from the target equation, I'm going to use these to come up with my strategy of how am I going to modify equation 1 and equation 2 so that when I add them together, they match the target. So if I start with equation 1 here, what I notice is I've got nitrogen gas and hydrogen gas. I've got 2 of these substances on the right-hand side. I have to come up with a strategy so that equation 1 will match the top. Now the question is do I use the nitrogen or do I use the hydrogen? And the answer to that question is I'm going to use the nitrogen. And the reason why is because nitrogen only appears in one spot in all of my working equations 1 and 2. So I'm using the nitrogen and I'm saying, okay, I need nitrogen to match the target. I've got 1 mole of nitrogen gas in equation 1, but I really only want a half mole of nitrogen to match the target up top. So my clue here is that to get equation 1 to match my target, I'm going to take everything and multiply it by 1/2. I'm going to rewrite equation 1 multiplying everything by that coefficient of 1/2, and I'm going to do the same thing to delta H1. I'm going to multiply this guy by 1/2 as well. Next up, I want to come up with my strategy for equation number 2. So for equation number 2, I've got water, I've got nitrogen dioxide, and I have the hydrogen. The question here is what do I use for my strategy? Because I've got 3 different substances from the target equation in equation number 2. The answer to this question is you could choose the water or you could choose the nitrogen dioxide, but you don't want to choose hydrogen. And the reason why you don't want to choose hydrogen is because it appears in more than one spot. It's in equation 1 and it's also in equation 2. So it's not easy for me to see how do I modify the equation to get the hydrogen to add up correctly. So what I'm going to do is I'm going to either use water or nitrogen dioxide. But what I notice about both of them is that in equation number 2, nitrogen dioxide appears on the right side. In my target equation, it's on the left. Same is true for the 2 moles of water. In equation 2, it's on the left side, but in my target equation, it's on the right. This is my clue that I've got to reverse this equation. I've got to write it backwards. So I'm going to start with nitrogen dioxide on the left. I'm going to take all of equation 2 and I'm going to reverse it. What happens to my delta H when I reverse that equation is that the sign is going to change. So it's kind of like multiplying it by -1. Instead of being 54 kilojoules for reaction 2, it's going to be -54 kilojoules. That sign is going to change. I'm going to stop here. I want you guys to try and work through the rest of this problem. Rewrite equation 1, rewrite equation 2, add them together, and do the same thing to your delta H's, and see if you can get that same answer. Check your answers with me. I'll post my answer